Hello everyone, my name is Eugene Bekinin and I am a senior engineer from Dodo Engineering, and today I will tell you how we integrated Apache Superset into our B2B platform. But first, a little bit about me. I have a more than 10 years experience in software development, and now I work as a senior data engineer in Dodo Engineering. And I am a leader of Superset integration project in our company. So, what does Dodo Engineering? We as an IT team serve our bigger company, Dodo Brands. Our company built on a franchising model and it consists of 3 quick service restaurant businesses: pizza, doner and coffee. We are presented in 16 countries and we have hundreds of our partners franchisees. Our colleagues from headquarters help our partners to do their business, and our IT team provide them digital solutions for everyday work. And our data team, we have a mission to gather data from this work, to gather it and to analyze it and to provide reports and analytics to all of them, to our partners and to our colleagues. And one of the goals is to implement or integrate some visualization tool such as Apache Superset. So here is my talk's agenda. First, I will tell you how we were choosing visualization tool and why we choose Superset. Then the main technical part of my talk. It consists of 3 stages: base deployment, customization and integration. And the last part, small part, about results and future plans. So, choosing visualization tools. Here are some prerequisites we have in mind. We have about 800 franchisee partners, clients who want to see analytics. We also have about 200 employees in our headquarters, and there are about 50 of them who creates dashboards. And we have a small team of 2 backend engineers and 1 front-end engineer, and we have this task a year ago in May of 2021. From these prerequisites, there are some requirements for the visualization tool. It should be free for big number of users. Many of you maybe know about Tableau. It is very powerful visualization tool, but it demands payment for every user, and it is suitable for small teams of analysts, and it was not suitable for us because we wanted to provide this service, these dashboards, for hundreds of our clients and partners. The second requirement: this tool should be written in Python, because we use Python in our everyday work, so it will be easier for us to adopt and modify this instrument. And the third one, but not the least, is the ability for customization and integration. It was really very important for us, and I will tell you why a bit later. So, keeping these requirements in mind, we finally were choosing between 2 instruments, Superset and Redash. So both of them are open source project and written in Python, so they met our 2 first conditions. And of course they have their pros and cons. They differ in their nature. For example, Redash, it has more simple user-friendly UI. It is more stable because of its monolithic code, and Superset, at the contrary, it is more complicated because of its modular code. It has more features, but they are complicated to set up them properly. It has also a bigger GitHub community, and but the main thing for us was the Superset's ability to separate backend for frontend due to its modular nature of the code. And this ability is really crucial for our goal to integrate this instrument into our B2B portal. So we choose Superset. Yeah, and Superset is a visualization tool. It provides a lot of dashboards and charts, for example, graph charts, bar charts, pie charts, heat maps, and new geographical maps. You can see a lot of examples in the left side of the slide. And in the right side of the slide, you can see an example of a graph chart created in a superset. Here you can see filters, labels, different colorful lines, and so on. Also, Superset supports a lot of databases, for example, MySQL, Postgres, MS SQL, Hive, Druid, Presto, and many others. And here is a small look at the Superset architecture. The main Superset application is written in Python, as I said before. It uses Flask Builder. Flask Builder is a modular framework to build web services in Python, so-called Flask web services. And as you know, Python is creates one-threaded application, so we need several instances of this application and a load balancer who splits requests among them in round robin, for example. Also, Superset has its own database in which it stores its metadata such as information about users, permissions, information about created dashboards, or maybe even saved requests. Here you can see in the left side of the slide, here it is a MySQL. In our case it is Postgres, it's okay. But the main Superset application doesn't execute users' requests itself. It delegates this work to salary workers, Superset salary workers. Here they shown in the bottom. So these salary workers, they grab tasks from the salary tasks queue from Redis. Redis acts as a cache and a task queue, and these workers execute queries against underlying database. As I said before, MySQL, Postgres, and so on. And then the main application renders results to the user. Our work can be divided into 3 stages: deploy, customize, and integration. And now we are going to deploy stage, base deployment. So we wanted to integrate Superset to our IT landscape. We store our data. Our data platform is based upon Delta Lake, and we use Azure Data Explorer as a serving layer for our data. So Azure Data Explorer is an underlying database for Superset. Also, we want users to log in using our custom Dodo IS provider, which implements OpenAuth 2.0 specification. And we gather logs in Kibana, and we show some usage metrics and gather them in Grafana. So, how to customize behavior and settings in Superset? The proper intended way is to use plugins. What are plugins? Plugins are really just variables or classes that you can change or add to the main Superset application. For example, we use them to customize authentication, loggers and login formatting, metrics, workers configuration, and other small changes in settings. Here in my talk I will show you 2 examples: authentication and loggers and log formatting. If you want to add, for example, support from Google OpenAuth provider, you just create this dictionary, Python dictionary with predefined standard keys like name, icon, client ID, client secret, and so on, and you just fill it with your own custom values. For example, Google key and Google secret. And the same dictionary, of course, with other values for your own custom provider if it supports OpenOAuth specification. For example, our own Dodo OpenOAuth provider, here you can see this another Python dictionary, and there are different values like Dodo key and Dodo secret. And then you just add these two dictionaries into a global variable list, OAuth providers, and if you add this global variable into a main Superset code, application code, then you will enable the support, enable users to log in using these two providers. And the same thing with many different other parts and components. For example, here you can see Dodo login configurator. It's not a dictionary or variable, it's a whole class with its logic. The same with Prometheus stats logger, we added it, and dashboard activity logger, where we collected our business related metrics about users. And yeah, we can the same add it in global variables such as stats logger or event logger. So to add plugin to the main Superset repository, you should somehow to add files containing this code into the main code. And what we have done, we created a repository, we call it Superset plugins, where we stored all these files with this plugin code. And then we created this build process. So we use GitHub Actions as a build service. It's really convenient for us because the code and the build tool are in the same site. And in this build process, we just download this Superset public image, I mean Docker public image. We extract it, and this is just a folder of Python files. And then we add our custom files from Superset plugins into it, and then pack it again into another Docker image and store it into our private registry. So you can see this Dodo/Superset custom image in private registry. And due to Pythonic nature, you can do this, because Python is a script language. It will see these new files when it will execute the main code. So everything was good except one thing. As I said before, we use Azure Data Explorer as an underlying database for Superset. And Superset supports a lot of databases, but it definitely hadn't support for Azure Data Explorer. And we needed to add it. Why we use Azure Data Explorer in the first place? This is a project from Microsoft. It is fully managed in Azure and hosted in Azure Cloud. It is fast and linearly scalable. It works well with structured and unstructured data. It was already adopted for 2 years in our company, and it's supported. And it has its own specific query language, Cousteau query language. And many people think that it is more expressive and powerful than the plain SQL. But for us it was a problem because Superset hadn't support KQL. And we added this support due to modular nature of a Superset. So how we can do it? You see, you need to create a custom engine. All other database supports realized using engine specs. So if you want to add support to a new database, you need to write your own engine spec, but engine spec uses SQL Alchemy dialect. SQL Alchemy is an ORM in Python for many different databases. Really not SQL Alchemy dialect itself, but not SQL Alchemy by itself, but SQL Alchemy dialects. There are a lot of dialects, for example, for MySQL, MS SQL, Postgres, Snowflake, and so on. So we created our own custom Custo SQL dialect. Then we connected this engine spec with this SQL dialect, and yeah, it worked like a charm. After we created this engine spec, we needed to create a new database, add a new database. So this database is not a standalone service database. This is an object inside Superset application, and it will process all queries against this service database, and it contains under the hood this engine. So here you can see the whole path of the query inside the Superset Python backend. First it goes into database, then it's processed by Custo engine spec, which adds some filters, limits, etc. And it creates SQL Alchemy query. This is an object, it looks like an abstract tree, which goes into SQL dialect that parses it into a string, query string. In our case, it is a kQuery string, and then it sends this query string into database, for example, Azure Data Explorer, and then gains results in response and renders it to the users. Yeah. So finally, we created this SQL Alchemy Custo dialect. We made it open sourced, and yes, it is now pretty simple and maybe even dumped in some cases. It doesn't cover the whole functionality of the language, but it does its work for us. So if you are interested in open source or in adding more support for Azure Data Explorer, please welcome. We are glad to any contributors. And then we add support for Azure Data Explorer in the main Superset branch, and it was released in May 2022 in a version 1.5. Yeah, but it was not quite ago from my presentation, and we added this support really for us maybe in half year before. So we needed somehow to work with what we have done. And then another second version of build scheme was born. You see, we forked this Apache Superset repository in the blue, and in this GitHub action build, in our fork, we changed some files, adding support for Azure Data Explorer into the main Apache Superset code. And then in this GitHub build action, we, as previously, copy this Docker Superset image, unpack it, add some files from Superset plugins, and substitute some files from the base image with our fork. And yet we gain again our custom Dodo Superset image with our plugins and Azure Data Explorer support. But this way is a bit dangerous and tricky, because we don't add some functionality, but we change files from the main branch. So we need to maintain the further changes in the main branch and public image in order not to break the whole application. So our strategy was to keep the amount of files we changed as small as possible and keep the changes as small as possible too. And after that, we have finally deployed this first version of Superset service in our company, and we let in first users, and these users were our colleagues from Business Intelligence team. They tried to create first dashboards, and they found some points of improvement in this service. And here let's go to the customization part. So how looks like a problem, a customization problem? You can see in the right part of the slide this bar chart and labels on the top of the bars. So there are no labels on the top of the bars in the plain vanilla superset, and it was a task for us to add these labels. Here came in play our front-end developer, and I need to tell you about front-end and about the Superset front-end architecture. It is also a bit complicated. You see, really, there are two repositories. The first one I mentioned before, it is Apache/Superset. It contains two parts. First part in the left, Flask App Builder Pythonic backend, and second part is Superset frontend written in JavaScript. This Superset frontend contains code for layout, user management, infrastructure code, interface, and so on, but it doesn't contain really code for charts, because the charts are maintained in another repository, Superset/Superset UI. These charts are built inside this repository and published into a global NPM registry, and this Superset frontend repository, it has dependencies on this NPM registry to download these bundles of UI plugins. So I will use UI plugins and charts interchangeably. They are the same in their terminology. So if you want to add a new chart to Superset, you should not do this in a Superset frontend, but you should do this in a Superset UI repository. And another thing I need to tell you about plugins. There are two types, legacy plugins and new, not legacy plugins. And legacy plugins, suggesting their name, they are not supported anymore. They are written using JavaScript, and the new ones using TypeScript. And also, so legacy plugins they use a legacy OAuth interaction with the backend. They use some endpoints in the API, backend API, that really restricted our integration, that prevented us to separate the whole frontend from backend. So we were sticked with new type of plugins, and we improved the new type of plugins. We do nothing with legacy plugins, except we converted one or two legacy plugins into non-legacy plugins. And to ease this work for our front-end developer, we created this scheme. So we also forked this Superset/Superset UI repository with UI plugins or charts. He made the changes in our fork, and then we published these charts into our local NPM registry. And keeping in mind these issues with the front end, we got the last build scheme. It's a bit complicated and consists of two build steps. So we forked two repositories, the main Apache Superset repository and the Superset UI repository with UI plugins. First, we use GitHub Action build frontend. Here we have a forked version of Dodo Superset. There is a changed code from frontend project because it has dependencies not on global NPM registry but on the local, on our NPM registry for some for the part of UI plugins which we have changed. And the result of this action is a Docker image, front-end image, but it's actually just a directory with files, bundles of built JavaScript code. And the second step, we call it build backend. It's the same as in the previous scheme. It also takes plugins and copies them into base Superset image. It modifies some file and substitute them from backend to add Azure Data Explorer support, and also it replaces the whole folder with JavaScript bundles in a main image, public image, with our custom bundles from Frontend image. And here we gain our custom Dodo Superset Docker image that we can deploy in production or in developer. And yeah, I think it was not very hard for you. So here how this web service, so-called Standalone Superset, looks like. You can see some dashboard, and in the left part there is a filter, and you can see in the left upper corner there is some customization made for us in our logo. So yeah, but it was not the way we wanted our partners and users will use Superset. Because, as I said before, our IT team provides an instrument, our B2B portal for our partners. And our partners spend a lot of time every working day in this portal, and it was not convenient for them to use this one side for their everyday work and another side to look through analytics. So our last goal, yeah, here you see we customized it already. So our last goal was to integrate this site, this Superset site, into our B2B portal. And now I need to talk a bit about our B2B portal. We call it Dodo IS, and it's really a multi-tool. It's a bunch of services under the hood. They are in the same site. And it has a lot of functions such as shift supervising, restaurant cash decks, food preparation tracker, delivery management, staff management, many other things. So they're all under the same site. And here you can see an example of a page of this portal. Yeah, it's handwritten by our company. And of course, Dodo IS had its own reporting part, but reporting was really ugly and poor. There were just tables and primitive graphs. You can see them in the left side of the slide. And what we wanted? Yeah, we wanted to add colorful and rich, complicated charts from Superset. And there were another bunch of problems with reporting in Dodo IS, because all the reports were created by developers and not analysts. They were embedded, the code of these queries was embedded in a monolithic application, and these queries were running against our production database, MySQL, which is not suitable for analytical load. And as I said before, they were really poor visualized. And it took from days to weeks to add a new dashboard into Dodo IS without business logic, I mean, because of all these reasons. And what we wanted to do, and what we wanted to provide analysts, and what we wanted, that analysts can create dashboards without help of developers, and these dashboards and reports will gain data not from MySQL but from analytical Azure Data Explorer. So here you can see integration scheme we used. In the left upper corner of this scheme, you can see simplified architecture of Frontend of two components. The dashboard component, which uses a layout component to call API from Superset backend. And what we wanted to extract this dashboards component and to integrate it into our Dodo IS frontend, and then proxy these requests to the Superset backend through our Dodo IS.NET backend. So this task divided into two backend tasks and front-end tasks. Let's see backend tasks. We needed to integrate two backend services: Dodo IS backend written in .NET and Superset backend API written in Python. There are different ways to integrate two backend services. We choose so-called shared secret. So how it works? You see a micro frontend, a frontend from Dodo IS sends a request to the backend. The backend has inside a component called proxy, which wraps this request with JSON web token. It adds this JSON web token in a header of this HTTP request, and this JSON web token is signed with this shared secret. And when Superset API gains this request, it can validate that this JSON web token is valid using its own copy of shared secret, and then return results in response. And this feature is there is no documentation in Superset about this feature, but because Superset is built using Flask App Builder, and Flask App Builder is really a modular framework, Flask App Builder has support for this interaction. You can easily enable it in plugins, just to set in a global variable GVT secret key your shared key, and in GVT identity claim you need to set a key name in JSON web token that can identify the user who created this request, and everything will work, of course with some tweaks. And about front-end integration, here is also a simplified scheme. There is a Superset client component inside a front-end, which themselves integrated into front-end layout. And there are a bunch of components such as SQL app, user profile, data source, charts, dashboards. They use this Superset client to call API from the backend. And what we wanted to do to extract this Superset client so it can work not in a Superset layout but in any other micro frontend, and we wanted to extract these two components, charts and dashboards, because we only really needed these two components integrated into our B2B portal. So here is this solution. Yeah, our front-end developer has changed the Superset client, so it can run not only in the Superset layout, but in any layout. He extracted these two components, charts and dashboards, and built them in a JavaScript bundle that is also stored in our private NPM registry. And when we now deploy our B2B portal Dodo IS, we can add this bundle as a micro frontend, so it will work inside Dodo IS. And here you can see how it looks like. This is the same dashboard I showed you before in a standalone Superset, but now it is wrapped with the layout of our B2B portal, so our partners have no need to go to other site to see analytics. They can just reach analytics in the same portal from a special tab. And yeah, this final milestone we completed. And I am going to results. Does anyone use our service? And the answer is yes. Here you see usage dashboard in Grafana. Here you can see monthly active users and weekly active users. This is not quite recent data. I just wanted to show you a picture how it looks like the statistics. And if we talk about results and future plans, our team of 2 backend engineers and 1 front-end engineer managed this task. We integrated Superset into Dodo IS in 1 year. They already created about 14 dashboards in this new service. There are about 200 monthly active users. So yeah, there's still not 800 users I mentioned before, but we are reaching this goal. We created 3 pull requests in the main Apache Superset repository, and also we started open source project SQL Alchemy Custo. There are already other plans, future plans. For example, we want to set up row-level security in our Superset service. This feature is already implemented in the main Superset, so we need just to configure and set up it in our service. Also, we want predefined defaults for filters, and this feature is really not implemented in a Superset, so maybe we need to create another pull request from us to add this. And what we haven't made in this year, we wanted to deploy the second instance, so-called developers Superset, as a sandbox for our ML engineers, so they can create their dashboards and reports here, and then we can export these dashboards into a production Superset for our partners. Yeah, really 30 minutes is not enough time to tell you about the whole work we have done in this year. I think the front-end part deserves its own presentation, so I have really omitted and simplified many things. And if you want to follow us in this way of integration, be prepared to face some surprising problems in many places, really. And if you have questions or you want to share your experience in Superset or integration, please contact me at LinkedIn. I will gladly answer your questions or collaborate with you. And here was Eugene Bekinian. Thank you.